All right, welcome to section 5.1, the law of sines. So, what we have learned so far from chapter 4 is that we worked everything with right triangles, and we still have all the tools from chapter 4 and how to solve anything with a right triangle. So, starting us off, here we have 2 out of 3 sides given in a right triangle. If that happens, you have to use the Pythagorean theorem to find x. That's the hypotenuse. So, basically your a squared plus b squared equals c squared. So 3 squared plus 4 squared equals x squared. And we can go solve for x. The other case is we have only one side given, but they give us one of our special angles. So we're looking at those special right triangles. Remember the 30, 60, 90 and the 45, 45, 90 triangles. Those are the two special right triangles where what we can do is you can find the other lengths of the sides based off the fact that you do have a 30-degree or a 60-degree acute angle, and you're given one of the two sides. So remember our triple ratio was A radical 3, 2A for your 30, 60, 90. So across from 30 degrees was A, across from 60 degrees was A radical 3, and across from 90 degrees was 2A. And wherever that one single side shows up, you're going to be able to solve for A. So I divide over the 2, and we can find this value for that side as A. It would be 2. This one would be 2 radical 3 for x. If you don't get your special 30 60s or 45 45 acute angles in a right triangle, then we got to use our trig ratios. In this case here is 43 degrees is our reference angle. X is opposite. 7 is the hypotenuse, so we would be using our trig function. Sine of 43 degrees is equal to x over 7. Multiply over the 7, and now we can solve for x. So the question is, what happens if, well, I give an angle of 50 degrees, 70 degrees. I go to find the third angle, 180. All three angles of a triangle must add up to be 180. Subtract the two given angles, I get 60 degrees. What happens if we don't have a right angle? And that's what we're going to focus on in chapter 5 here. So a triangle with no right angle is called an oblique triangle. Now, oblique triangles are made up of two types of triangles based on their angles: acute triangles and obtuse triangles. That's what we're going to investigate now. So what we have to do is we're probably going to have to look at all of our possibilities, and in some way, shape, or form, we got to bring our right triangles back into place so we can develop some laws, if you will, and how to solve for angles and to solve for sides. So for our oblique triangles, you've probably seen some of this notation from your geometry days in high school. So case 1, you're looking at when you're given one side and two angles. This is the best case scenario because as you saw, let's jump back here real quick, you were given two angles, you can immediately find the third. And if you have all three angles, that's going to be a plus for solving for missing sides. So this is a great version right here. Case number 2, two sides and one angle not included between the two sides are known. This is called the side-side angle. Now, I prefer to call it the angle side-side because it is a real pain in the angle side-side because as you can see, you can have more than one triangle. So looking at my triangles here, angle, angle, side. Remember these congruent arcs and tick marks? These angles aren't congruent because they're not the same, but here's the side. It's not included, which means it's not in between the two angles that are given. So this would be either known as an angle, angle, side, or side, angle, angle. Your angle, side, angle, there's the tick mark in between the two given angles. Your angle, side, side, or side, side, angle, again, I prefer to call it angle side side because usually when you build this triangle, you want to put the given angle in the lower left-hand corner, draw it to scale, draw this side somewhat to scale, but be proportional to this one over here. And when we look at examples, you'll see, come on, cursor, you'll see why we want to do that. Case 3, two sides and the angle included between the two sides. This is known as the side angle side. You might remember this as the side angle side postulate or the angle side angle postulate. Remember all those postulates from geometry where these letters are used. Here, the two sides that are given make up the included angle. So all three of these are given, and they're all connected together, which is different than what we had up here and where this side was not included. This side was included between the two angles. This angle is included, it's between the two sides. As you can see here, this angle is not included. That's going to cause problems. That's why I like to call it the angle side situation or case. And then of course our side, you know all three sides, but you don't know any angles. And that's the part we're going to have to work on, finding those angles. So looking at case 1, let's go to this case here and work on how to develop that law of sines. So as it says, to derive the law of sines, we start with an oblique triangle and construct the perpendicular from B. And again, that perpendicular can come from B to AC or A to BC or C to BA. It doesn't matter. All right, so where that perpendicular comes down, we're going to call it D. So what that does is that gives me two right triangles, triangle A, B, D, and right triangle C, B, D, where D, of course, is going to be our right angle. We're going to have to find the height, because this height is being shared between this triangle on the left, this right triangle on the left, and the right triangle on the right. So let's use angle A as my reference angle. Opposite of A is H over hypotenuse C. Then what we're going to do is we're going to solve this for H by simply multiplying both sides by C. Well, how about at the same time we also look at the right triangle? Let's do this, both right triangles at the same time. Angle C is my reference angle. Opposite side again is H over hypotenuse A. So here's my two trig ratios. To solve for H in both cases, on the left we'll multiply both sides by C. On the right we'll multiply both sides by A. So we have sine of A being multiplied by C. We'll say that's equal to H. And over here we'll have side A being multiplied to the sine of angle C. Since they're both equal to H, we're going to use a little substitution here. So let's take A times sine of angle C, put that in for H, and rewrite that equation. So what does this give for me? Well, actually, it's tough to see, but this is one of our properties of proportions. This is technically a proportion written out as the cross product. So let's turn it back into a fraction. So here's what we're going to do. I'm going to take sine of A and divide it to both sides to get this C by itself. So there's that division. And then over on the right, I'm going to divide sine of C away from the right and move that over to the left. Remember, we're trying to create a proportion. One fraction equal to another fraction. So go ahead and cross out your sine A's, cross out your sine C's, and here's my proportion. Which is really convenient because notice that my ratios here is the side opposite of angle C is over the sine of angle C. Side A, which is opposite of angle A, is over the sine of angle A. Now, what would be nice is if, let's get angle B and, if you will, side B involved in this. So here's side B. It's from A to C. And now my perpendicular from A to BC gives me two skinny right triangles. So we're going to find the sine setups again. So now B is my reference angle. Opposite of B is H over hypotenuse C, and that skinny little right triangle there. And then this right triangle here we'll use again angle C as the reference angle. Now it's this height, that new height we put in, over the hypotenuse B. So take a look at these two ratios and say to yourself, hey, wait a minute. This setup is very similar to what we had right here. Sine A equals H over C. So I put in the B instead. There's my same ratio. Sine C is now equal to H over A. So the new lettering here is just that capital B, angle B, goes in for angle A, and little a is replaced with little b. So my work will be the same. So let's just go down to my proportion and say, okay, little a is replaced with little b. Angle A is replaced with angle B, and that's going to be equal to this ratio C over sine of angle C. Okay, there you go. You have what is known as a triple proportion. Just like we said with the 30, 60, 90 and a 45, 45, 90. 30, 60, 90. That was a triple ratio. A colon A radical 3 colon 2A. That's a triple ratio. Okay, this is a triple proportion. 3 fractions set equal together. This is my law of sines. So we'll fill that in our note sheets right here. So any given triangle, ABC, where the sides opposite your angles are the lowercase letters, that's the way we always set it up, you will have A over the sine of angle A, B over the sine of angle B, C over the sine of angle C. They like to put this in alphabetical order. It doesn't matter what order this comes in. That's going to be important when we look at our examples. An alternative form of the law of sines is just to flip everything. Bottom goes to the top, top goes to the bottom. Now, a lot of authors and other teachers believe in this alternative sign setup. I don't give a rat's hoot. Because when you look at a proportion, when you look at two fractions equal to each other, to solve a proportion, you cross multiply. So it doesn't matter where the unknown variable is located. All right, and I'll show you that because our proportions are going to be used to set up calculator entries, and your calculator entry is going to be showing me your work. So you must write it down. I give points on the exam for how you write down your calculator entry. It's 2 points, and then it's 1 point for the correct answer that the calculator gives me. If you just try to get to the correct answer and it comes up wrong, you lose 3 points. This way, if you accidentally type something wrong into the calculator, but you wrote it down right, or like you forgot to change the mode from radians to degrees, you only lose 1 point. You lose all 3 points. So always write down your calculator entries for this stuff in Chapter 5. It's going to be very important. And the other thing that we're going to talk about quickly with calculators here, use the store button. You get some ugly angles with minutes or seconds. You don't want to have to type all that in because that's time consuming.